I'm Likhitha. Welcome back to my YouTube channel Code to Create. In today's video, we're going to see how to create a model that predicts if the cell image is having a malaria parasite or not. So let's get started. First, let me show you guys how does it work. Let me say select image. Let me just get an image. And this should predict, yes, malaria parasitized. So now let's move to Jupyter Notebook and see how to create this model. First, I have imported numpy as np for the calculations if there is in the cell image if there is a parasite or not. And then we need matplotlib for the matrix, and we need images over here from pil import image. We need image for seeing if it's parasitized or not. And then we need OS for reading and saving. And then we need CV2. And then we need Keras. From Keras I have imported sequential. And from Keras I have imported conversional 2D and max pooling 2D, dense, flatten and dropout. Dense, max pooling 2D, dense, flatten and dropout. All of them I have used in neural networks itself. In the network. And then I have used shuffle for random.shuffle. You guys will know that. And then we need SK image. This is from the sklearn image. So I have imported the SK image. That is also for the images. And then we need resizing because we need to resize the image of the cell. And then we need random for the shuffling part. And after that I've read the cell images that is over here. Let me show it to you guys. Here, yes. You have all the parasitized images and uninfected images. I've read both the parasitized and uninfected images into paradir and uninfected dir. And then we need Pimangus and Nimangus. Pimangus is going to be of the one which is infected, the data set which is infected, and the other Nimangus is going to be of the uninfected cell images. And then I've told data is equal to just an empty list. We need this variable, so I've told data is equal to empty list and labels is equal to an empty list. And then I told parasitized is equal to os.listdir. Here inside this we have created a list that is going to be parasitized, and that's going to be the cell images of infected people. And then I've created a for loop saying for a in parasitized, for each and every image in parasitized. I'm going to read this image plus a. Do not worry about this a. I'm going to read this parasitized images, and then I've told images from array is equal to image from array of all the RGB images. So if we're gonna try this, and I've told try to read this up, and if you are able to read, then we're gonna save that. We're gonna store it. We are gonna store it in the form of an array, and saying that this is going to be all of RGBs. And then I've told size of the image. I have put the size over here to 50 pixel from both height and width. And then I've told data.append np.array size image. We have appended this size image into data. And then I told label append 0. That don't worry about it. And then I've told accept attribute error. If while doing this process, if we get an error, we're gonna say that accept this attribute error and just don't print anything. Just print an empty line. And then I've come out of this for loop. And I've created a variable called uninfected, and I've read this uninfected cell images. And then I told for b in uninfected. That means for each and every cell images in uninfected cell images. For each and every cell image in uninfected cell images, we're gonna try to read that, convert it into an array, and then resize it up. The same thing that we did for the infected. And I've appended labels.1. Here we have appended 0 and 1. Because we have to display, if it's 0, then we're going to say that it's parasitized. And if it's 1, we're going to say it's not parasitized. And if it's an error, if there is any error, any attribute error, I'm going to accept that attribute error and print an empty line. And then I'm going to say cell is equal to np.array data. I have got this data from here, the empty list. So I'm gonna convert whatever is there in data, whatever I store it in data. I'll convert into an array and store it in cells. And the same I have done to labels. I have converted this labels into an array and stored it in labels. And then I told np.save cells as cells and labels as labels. So I've set their heading, and I told cells.np load cells.npy labels.npy. I have just loaded this up, and then I'm going to say s is equal to np.array cells shape. I have arranged this up cells, so I'm going to say the shape as 0. And then I have shuffled everything, whatever the cells I have, I've shuffled everything so that we can predict and train it up. And then I told cells is equal to cells of S, whatever cells we have. So we have completed this, saying we have mixed this parasitized and uninfected. And labels is equal to labels of S. And then I told number of classes is equal to length of np.unique labels. Here we're going to get the unique labels and store it in number of classes. And length of data, I'm going to store it in length of cells. Whatever number of cells we have, that is the length of the data. And then I've told xtrain, ytest, xtest. And then I've told xtrain, xtest is equal to cell of integer 0.1 multiplied by the length of data and 0.1 multiplied by the length of data. So I have multiplied both of this, that means the square of. So this is just like a formula for training and testing. This is just going to be like we're going to choose the length, the cell's length. So we have chosen it randomly. I've told integer of 0.1 length data, comma integer of 0.1 length data. And then I've told xtrain is equal to xtrain.as type float. I've converted this. I'm going to divide it by 225 as we're working on an image data. We have to normalize it. As we are working on an image data, we have to normalize this up first. So for that I have divided by 255, and the same for xtest I have divided by 255. And then I have told the length of xtrain and xtest, train length, test length. And then I have done the same thing for the ytrain and ytest. So we have divided everything like xtrain, xtest, ytrain and ytest. And then I have told y is equal to keras.utils to categorical. We have converted this data set into categorical of ytrain and number of classes. And the same we have done to xtest. We have converted into categorical, and we have told ytest comma number of classes. And I have imported this early stopping and model checkpoint. And then I have plotted this random seed as 0. And here comes the neural networks, that is, I have set the model to sequential, and I told model that add conversion, and then I have told model dot add con2d and filters is equal to 32 kernels. If you haven't, yes, here comes the neural network. Model is equal to sequence. Here comes the neural network. If you guys haven't watched my video of neural networks, please do watch it and get back to my video. I've told model is equal to sequential, that's the import of sequential. That's from keras. And then I've told model dot add con2d, filters as 32, kernel size as 2, padding as same, activation as ReLU, input size it's going to be 5053. And I've told model dot add max pooling 2d, pool size is equal to 2. Dropout is equal to 0.2. I have done the same thing. And then I've got this summary. That is model is equal to sequential. I'm going to put the layer type over here, convolutional 2D, and the shape, output shape is going to be 50, 50, 32. Is 416 parameters over here. So this is going to be the model summary over here till now what we did. And then I'm going to tell model.compile loss is equal to binary cross trophy and optimizer is equal to Adam, matrix is equal to accuracy. Here I've just got the accuracy and the matrix that we need I've told callbacks is equal to early stopping monitor is equal to while loss, patience is equal to 2. And then I've converted this into model watch.hdf5. Monitor is equal to while loss, save best only is equal to true. So whatever we did till now, I've saved it in the callbacks. And then I've fit this up. I fit everything what I did here. I've fit everything into h. And I've told model.fit xtrain, ytrain. Batch size is equal to 32. Callbacks is equal to callback. Validation is equal to xtest and ytest. Epoch is equal to 20 and verbose is equal to 2. Here it's done out 10 out of 20. That's absolutely fine. And then I've told load text. I have imported from NumPy. I have imported load text. And I told from keras.models import load model. And then I'm gonna import this model watch.hdf5. That is right here. We have saved it. Yes, it's right here. We have told model checkpoint. So we have loaded this model checkpoint and we have told score is equal to model.evaluate. This is all going to be the score. So I'm going to say load model. I've loaded this model for score and then I've told score is equal to model.evaluate, xtest and ytest, and then I've printed the score and that's here. The accuracy is 95%. And it took 2 seconds, 16 milliseconds for every step. And then I'm going to say accuracy is equal to model.evaluate. And then I've evaluated the accuracy over here. That is going to be 95%. The accuracy is, the test accuracy is going to be 95%. And then I've imported this confusion matrix and I have first loaded this into, and then I've imported the confusion matrix. And inside this confusion matrix, before we get the confusion matrix, we need to predict for the confusion matrix. So I'm going to say pred is equal to model.predict xtest. And then I'm going to say pred is equal to model.predict xtest. And then I'm going to say pred is equal to np.argmax. I'm going to get the maximum argument and I'm going to say predict comma axis is equal to 1. So we have predicted it and we have told y underscore true is equal to argmax ytest. And then I've got the confusion matrix. Now I've told cm is equal to confusion matrix, the import confusion matrix of x underscore true comma predict. So x true is y true is going to be the ytest. And this prediction, pred is going to be the prediction that we have done from the xtest. So I have imported this plot confusion matrix from ML extend. If it's going to show saying that no model called as ML extend, what you're going to do is open up the Anaconda prompt and we're going to say pip install ML extend. Yes, for me it's already done. So it shows requirement already satisfied. You can see the plot is here. You have the true label and the predicted label. Yeah, these both are going to be the predicted label and these both are going to be the true label. So this is the prediction. And then I've told model pred is equal to model.predict xtest, batch size is equal to 1 and I've got the argmax. And then I've told pred 0, we've got 0 and it shows 1 2 because we're going to say that if person is having malaria. If the cell image is having malaria parasitized or no. If it's having, it's 0. If it doesn't have, it's 1. And then I've saved this model completely. So I've told model.save. I've stored it in this web app disease detection. And then I've told y@ is equal to model.predict xtest, malaria labels, parasitized and uninfected. So now let me show you guys the final prediction. Okay, let me run it from and then I've told y@ is equal to model.predict xtest and I've told malaria labels is parasitized or uninfected. So we have completed the prediction part. Now let's move to the front-end part, that's in Spyder and Visual Studio Code. Let me create a new file here and name this file. Okay. Yeah, let's begin the front-end part. First we have to import division and print function because we have to print the result over here, and then we have to divide for because we are dealing with images. So I'm going to say from __ future _ import division comma print function. Both are from the future itself, _ future. And then I'm going to import this OS for loading the file. I'm going to print numpy for the calculations. Import numpy as MP. And then now I'm going to import all the TensorFlow ones, that's backend. For getting the front end, we need to import the backend. So I'm going to say from, and then comes the TensorFlow. I'm going to import backend as K. So let me import that. I'm going to say from tensorflow.keras import backend as K. I'm going to import it as K. I'm going to come down and import image2 from TensorFlow itself. So I'm going to say from TensorFlow. I'm going to say from tensorflow.keras.preprocessing import image. Okay, that's an image, yes. And then I'm going to import from the flask. So let's do that. I'm going to say from flask import flask. Okay, import flask comma request. We need request to post, and then we need a render template for getting the front end. That is going to be the from. That's going to be. We need to import this render template because we have to get the front end. That's from Visual Studio Code. That is the HTML part. And then I'm going to import secure file name for getting the image. So I'm going to say from workzeg import secure _ file name. And then I'm going to say app is equal to flask I'm going to say flask _ name _ comma template _ folder is equal to templates. So it's just saying that where do we get this templates from. So that one we're going to get it from the templates folder. So yes. And then I'm going to get my model path. I'm going to say model is equal to, okay, first let me run this. Yes, after running this, I'm going to open cannot import secure file name from work. Okay, let's do one thing. Let's move up here and say pip install workzeg. Okay, so let me install that up. I'm going to install workzeg. I'm going to say pip install work. Should work. Yes, requirement already satisfied and is not imported but unused. There is some error. Cannot import secure file name. So I'm going to import workzeg.utils from workzeg.utils import. This should work. Yes, it worked. So after completing, let me save this file up, and I'm going to save this as app video. I'm going to save this as app video, and I'm going to say save. Yes. And after getting this templates and importing the necessary libraries, after After importing the necessary libraries and saying app is equal to and getting the template, I'm going to store the model path. Model path is going to be what we have done the prediction in Jupyter notebook. So that one I'm going to get it. Let me go to my file, and that is in downloads. Sorry, that is here, and yeah, my model.h5. Get that and that. Yes, R. Let's see if the file is there. Yes. After this, that's done. We're gonna say slash my underscore model dot h5. Let me run this. Yes. After doing this, I'm gonna say I'm gonna load my model. So I'm gonna load my model. So I'm gonna say model is equal to load underscore model, and we're gonna load the model path. Yes. Load model is not there. Load model should be there. While importing the image, I have imported load model. Oh yeah, we forgot it. We forgot to import the load. Yeah, we forgot to do a few more imports. So let's do that. First, we have to say that we're gonna say that k dot clear underscore session, and I'm gonna call the session clear. I'm gonna clear all the backend part. I'm gonna clear session over here from the backend, and then here I'm gonna import I'm gonna import load model now. I'm gonna say from tensor flow dot keras dot model import keras dot models import load underscore model. Yes, that is gone. And I'm gonna print out. I'm gonna print saying model loaded start serving. And now I'm gonna create a function called as make predict and now I'm gonna create a function called as model predict. So let me see model underscore predict image underscore path comma model, and inside this function I'm gonna store the image first. I'm gonna say image is equal to image dot load underscore image, and here I'm gonna give the image path comma target size is equal to 50 equal to 50 50 comma 50. And after this I'm gonna say image is equal to image dot image to array. What I did here was I'm gonna convert this whatever image we have stored over here. I'm gonna convert this into a array. So I've told image array image to array, and I'm gonna get the image here. I want to convert this image into a array, so I've told that I've stored that inside image, and I'm gonna say image is equal to np dot expand underscore dims of image and access. I'm gonna say expand dims. I'm gonna expand this dims layer. After that, okay, there's an error. No, okay. And then I'm gonna predict now. I'm gonna say pred is equal to model dot predict image, and I'm gonna return the prediction over here. Okay, we have to say pred is equal to np.arg, let's say argmax, np.argmax of threads comma access equals 1. And then I've returned this prediction in the function of model predict. And now we need to create two more functions. That's going to be index. That means we have to return to the index. That's all. And then we have upload function. First, let me create this def index return render template, and the template is index.html. Okay, that template is index.html. And now we have to create the function that is upload. If upload, this is all going to be of the uploading part. So I've copied this upload from my reference file, and I've copied this function upload from my reference file. That's all about uploading the image. So I've told def upload. Here we need the request method, because we have to post the file, we have to get the file, right? So we need the request method, and I've set the request method to post. And then I'm gonna get this file, so I'm gonna say f is equal to request file of files of file. So now we're gonna get access to they're gonna get access to files in this app. And then I'm gonna say paste path is equal to os.path.dirname file. So I've saved this file into uploads. And then I've told file path is equal to os.path join uploads. I've set the base path. I have to save the file inside upload. So first I've got this up. I've got this up. I've got the file, and then I've told file path is equal to os.path.join base path and uploads. And then I've told secure file name f.filename file.save file path. So I've saved this inside the file path, and then I have to make prediction over here. So I've told pred is equal to model underscore predict file path of model. I'm gonna predict this model file path, and I've told os.remove file path, because we have saved it inside the pred. Because we have already completed the prediction, I'm gonna remove this up. And then I've told string 1 is malaria parasitized, string 2 is normal. If prediction is 0, then I'm gonna print the string 1, that's malaria parasitized. Or else, that means if it's going to be 1, I'm going to print the string 2, that is normal. And then I've returned none. I don't want to return anything. I've told if, and then I've created a if condition saying if underscore underscore name. This is just for running in a port of 5002. This if condition is just to run a file in the port of 5002. Yes, if underscore underscore name is equal to underscore underscore main, then I've told app.run port threaded is equal to false. Now let's move to the front end part, that means the HTML part. I've created a body over here, and I completely printed what is it, and I've told its accuracy over here, that the person, how much the cell is parasitized, the percentage that the cell is parasitized, and I have put the procedure saying click the image and then click on the button predict. It will run in the background and give you the output. And then I've created a label select image, and I've created an input that is going to be of the upload part. So I've told type is equal to file, name is equal to file, ID is equal to image upload. And then I've accepted PNG, JPG and JPEG. These are the types, I have accepted PNG, JPG and JPEG. And then I have put a button inside a division, and I have set the button's class as button primary and ID as button predict, and I have set the text as predict. And then I've told the result will be printed in this base.html, and I have put all the procedures over here, what to do and what did we do. That convolutional layer, how many convolutional layer, how many how many convolutional layer and how many pooling layers and how many fully connected, and total number of. I've printed this convolutional layer, I've printed this pooling layer, and total number of hidden units. And I've told end block, it goes to the base HTML, that's here. And here we have done nothing, but here what we did was we have just printed the prediction text. So I've told ID content style is equal to margin top and block content end block. That here we're gonna print out the prediction text up. That's why we have used the block content and end block. Okay, yes, that's why we use the block content and end block. And then at the end I've put few CSS and JavaScript code up. And at the end I have put CSS code up. I have called the styling part up. So now let me run it to you guys and show it. I'm going to say cd. First you have to get the path of the file what you want to run. So I've got it, and then I'm going to say python app_video.py. I'm going to run this. There should not be any type of error. Let me come here. Yes. Okay. Everything is right. Oh yeah, we have to save this up first. Yes, after saving, let's try to rerun this up. So I'm gonna say python app_video.py. Yes, you got the link. So let me copy up this link and let me paste it here. Yes, you've got this, the percentage of accuracy that I've showed here, I've printed out here in the index.html, and then I've told the procedure, and then you have the button select image that helps us to select the image. Let me select a parasitized image. Yes, result malaria parasitized. And then I've told in purpose scheme how many layers we have in CNN. So yeah, now we know how to predict if the cell image is parasitized or not. That's great. Thank you friends. Please do like, share, subscribe and comment below. Bye bye.